Now let's transform a general equation to its slope and symmetric form. Let's see the slope form first. This is the general equation of a line. And now let's arrange it into the form y is equal to mx plus c, where m is the gradient and c is the the y-intercept. So let's take this ax to the right-hand side and the c to the right-hand side as well. So by is equal to minus ax minus c. Y is equal to minus a over bx minus c over b. And this is your m, and this is your c, or this is the gradient, and this is the y-intercept. Now to calculate the symmetric form, you need to find another point on the line apart from the gradient, apart from the y-intercept. So then the easiest one is to just find the x-intercept. And the way to find the x-intercept is to put this y over here equal to 0, right? Because in the x-intercept, the y value is 0. In the y-intercept, the x value is 0. So y is equal to sorry, my bad. Let's take the general equation. It's easier to calculate. So ax plus b into 0, because y is equal to 0, plus c, and that's equal to 0. So now ax is equal to negative c, and x is equal to minus c over a, right? So the coordinates of the x-intercept are minus c over a and 0. Now this is needed for the symmetric form, but for the point slope form, you just need to fiddle with this y is equal to mx plus c equation, right? Or in this case, y is equal to minus a over b x minus c over b. Now what you need to do is, you need to take this slope minus a over b common, right? And that will eventually lead you to this equation, right? And the thing is that you need to have the c over a over here, because if you take minus a over b common from both of these terms, right, you need to divide the c with a, so that when you multiply both of these terms, they eventually give you negative c over b, right? And indeed, in this case, when you will multiply this minus a over b with this c over a, this a and this a, they cancel out, and that eventually leaves you with minus c over b. Okay, and this is now the point slope form, but you won't deal with this much. You'll deal with more with the symmetric form. So we already know that the gradient, or m, is equal to minus a over b, but that is also equal to tan alpha. So if you draw the coordinate axis, and let's just assume that this is the line given to us, right? And this is your alpha, and we already know that the gradient is equal to the rise over the run. This is your rise, and this is your run, right? So the rise is equal to a, in this case negative a, and the run is equal to b, right? So the y value is negative a and the x value is b, and tan alpha is equal to the rise over the run. And so now let's see what sine alpha is equal to. Sine alpha is equal to the rise over the hypotenuse, and the hypotenuse, if you remember the Pythagorean theorem, is equal to a square plus b square whole under root, right? Not negative a square, because negative a square and positive a square is the same thing, right? So now you have this as the hypotenuse. So now sine alpha is equal to a over plus minus under root a square plus b square, and similarly cos alpha is equal to the run over the hypotenuse, so b over under root a square plus b square. Now that you have this, let's see the equation in the symmetric form. The symmetric form equation was x minus x1 over cos alpha, which is equal to y minus y1 over sine alpha, and that is equal to some constant r, right? And this x1 and y1 comes from the point, which is the x-intercept. So x1 is equal to minus c over a, and y1 is equal to 0. And hence you get, and we already know that cos alpha is this, this, and sine alpha is this, right? So once you plug those values in, you get this. And this is the symmetric form.